All right, guys, back at it. So we are going to be working on the unit circle this week. I know you guys have heard me bring up that unit circle before, one of the most important tools in mathematics. This right here is a blank unit circle we'll be working on all week long, and at the end of the week it'll look something like this. Okay, this is a complete unit circle. Okay, now we have a number of different angle measures here. If you'll notice, these guys here are all in degrees, 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 degrees. But then out here you have something that looks a little bit different. There's 0 and 2 pi, there's pi over 6, there's pi over 4, pi over 3, and so on. These guys out here are a different way of measuring angle measures. It's called radians, okay, not degrees. Now, we don't have to worry about that this year in geometry. That's a pre-calc topic, and if you come back to me for pre-calc, I'll teach you about radians. So we're just worried about the degrees, okay, here all the way around, and then these coordinates, okay, on the outside. That's what we're worried about. Okay, so we will be working on filling all this in, okay, where we will have, we always start like right here. Okay, this is 0 degrees, and if you go all the way around counterclockwise, you end up at 360 degrees like that. And then what we do is we rotate starting at 0 degrees, and we rotate counterclockwise. So we'd rotate here, and that would form an angle with a very specific measure. Then we'd rotate here, that would form an angle with a very specific measure. We'd rotate here, and that would form an angle with a very specific measure. And then we'd rotate straight up, which obviously it does give you 90 degrees there. That guy would end up being 90 pesos right here. Okay, so today we're primarily just going to work in quadrant 1, filling this stuff out in quadrant 1. Okay, now everything in the unit circle is based on our special right triangles, our 45, 45, and our 30, 60, 90. Okay, so I know we did this earlier in the year, but some of you probably need to be reminded of it. Okay, now all we're worried about is sine and cosine here. Okay, this stuff, if we were in school and I had more time to teach you, we'd deal with tangent, but we don't have that. Okay, we don't have that ability for you to be sitting in my classroom like you did all year long, and we'd be able to deal with all of it. Okay, and so we've got to deal with sine and cosine of 45, and then down here, we've got to deal with the sine and cosine of not only 30 degrees, but 60 degrees as well. And the stuff with tangent, again, we don't have the ability to do that right now because of our circumstances. Okay, so we go back, okay, and we did, like I said, we did this early in the year, and we'll keep coming back to these two sheets. Okay, so remember sine, okay, is opposite over hypotenuse, okay, and remember cosine is adjacent over hypotenuse. Okay, and in a 45, 45, 90, we know the two legs have the same exact measure, and we know that the hypotenuse is always equal to a length of a leg times radical 2. Okay, so if we do sine of 45, notice that it's not going to matter which 45-degree angle I work with. So if I go sine of this 45, I'm going to get opposite A over hypotenuse A radical 2. Or if I do the sine of this 45, notice it's going to be opposite A over the hypotenuse A radical 2. So it's not going to matter which 45-degree angle I work with. So I'll just work with this one. So I get opposite over hypotenuse. Okay, so I get A over A radical 2. Okay, so notice the A's in the numerator cancel each other off. So I get the sine of 45 is just equal to 1 over radical 2. And then we rationalize that. Okay, so the sine of 45 degrees, I would have to multiply above and below by radical 2. Okay, so the sine of 45 degrees is radical 2 over 2. Okay, all right, so we have that. All right, now I do cosine. Okay, so I got to do the cosine of 45 degrees. And once again, notice that both of these are 45 degrees. It doesn't matter which one I use. Just like with sine, I could have used either one. It's the same thing with cosine. I can use either one. So we do adjacent over hypotenuse. So the sine of 45, I'll use this guy down here, is adjacent over hypotenuse. Okay, so a over a radical 2. And notice this guy is the exact same thing as over here. So when I go through all of this, I know I'm going to get the cosine of 45 degrees is equal to radical 2 over 2. All right, now this makes sense to me because we're dealing with an isosceles right triangle. Okay, so it would make sense that the sine and cosine, okay, of the acute angles would be exactly the same. Okay, so we're good there. All right, and we'll come back to this guy. Okay, now we have to deal with sine and cosine of the 30 degrees and the 60 degrees in a 30, 60, 90. Okay, so remember, in a 30, 60, 90, everything is dependent on the short leg, which is opposite the 30-degree angle. So if we let that short leg be A, the hypotenuse is always 2 times the short leg. So if the short leg is A, the hypotenuse has to be 2 times A. And the longer leg, which is opposite the 60-degree angle, okay, would have to be the short times radical 3, so we get A radical 3. Okay, so I've got to deal with the 30-degree angle, and I've got to deal with the 60-degree angle. And again, we're only doing sine and cosine. Okay, so if I do the sine of 30 degrees, okay, so I start here and I go opposite over hypotenuse, so I get A over 2A. And notice the A's cancel each other out, and I get the sine of 30 degrees is equal to 1/2. Okay, that guy's real important. Okay, now I'm going to do the cosine of 30. Okay, so the cosine of 30 would be adjacent over hypotenuse. So we get A radical 3 over 2A. A radical 3 over 2A. And notice again, the A's cancel each other out. So I get the cosine of 30 degrees is radical 3 over 2. Okay, so that guy's real important. Okay, now I have to do the same thing for 60 degrees. So I'm going to do sine first. So we go the sine of 60 pesos equals, okay, here's my 60. So I go opposite over hypotenuse. So I get A radical 3 over 2A. A radical 3 over 2A. And notice the A's cancel each other out. And so I get the sine of 60 pesos is equal to radical 3 over 2. Now, we should expect that because remember, in a right triangle, with respect to the 2 acute angles, the sine of one acute angle is equal to the cosine of the other. So we would expect the sine of 60 and the cosine of 30 to be exactly the same. Okay. All right, so let's do cosine of 60. Okay, so we go cosine of 60, so it's adjacent A over hypotenuse 2A. So that's A over 2A. And notice the A's cancel each other out, so we get the cosine of 60 pesos equals 1/2. And that guy is real important. And once again, the 30 and the 60 degrees are the 2 acute angles in a right triangle, so we would expect the sine of one acute angle to be equal to the cosine of the other. So the sine of 30 and the cosine of 60 have to give you the exact same thing. Okay, once again, okay, these 2 sheets, this guy and this guy, we're going to come back to them. They're really, really, really important. Okay, so we start taking a look at, well, what is the unit circle exactly? Okay, the unit circle is a circle whose center is at the origin and has a radius of 1. So that means, okay, this is a radius, that's a radius, this is a radius, and that's a radius. Okay, and all radii are 1. So right here, this point where the circle intersects the x-axis over here between quadrants 1 and quadrant 4, that would be a radius, so that point would be at 1, 0. okay, over here, okay, this point where the circle intersects the x-axis between quadrant 2 and quadrant 3, well, that's a radius, okay, so the coordinates of that point, remember the radius is 1, would be negative 1, 0, okay. Okay, this is a radius here, so where the circle intersects or intercepts that y-axis, okay, that would be a radius, so the coordinates there would be 0, 1, and then this is another radius here, okay. Remember, all radii are 1 because it's a unit circle, so where the center intercepts or intersects the y-axis down here between quadrants 3 and 4, that'd be at 0, negative 1, okay, and then we have these special angles, and we always start at 0 degrees, which would be right here, okay, where you start on the x-axis, and we would rotate counterclockwise to form angles. Okay, so we have this angle of rotation in here. Let's suppose I start here and I just rotate to there, okay, and so that angle of rotation, we normally use theta for that, although you could use something else, that's up to you, okay. And so right here where this side of the angle that's formed by rotating counterclockwise, that guy intersects the circle at some random point, I'll call point P, and it has obviously coordinates x, y. Okay, so that means that if I drop a vertical line straight down to the x-axis and form a right angle, I've got a right triangle in here. Okay, and obviously this leg, okay, would be my x coordinate, and this leg right here would be my y coordinate. Okay, and so we want to take a look at, okay, how about some sine and cosine of this right triangle? Okay, so we say, okay, theta is an acute angle, okay, in this right triangle, and it's also this really important angle of rotation. So if I look at the sine of theta, well, it would be opposite y over hypotenuse 1. So you get y over 1. So that means the sine of theta is just equal to y. Okay, so that means this guy right here, this y coordinate has to be the sine of theta, whatever that is. Okay, let's look at the cosine. Cosine of theta. Okay, so cosine of theta, well, that would be adjacent over hypotenuse, so you'd get x over 1. So that's just x over 1. Okay, so that means the cosine of theta is equal to x. Well, that's the x coordinate of this point right here. So that's cosine of theta. Okay, so that means anywhere on the unit circle, okay, all right, anywhere on the unit circle, anywhere at all, okay, the coordinates are always cosine of theta is your x coordinate and sine of theta is your y coordinate. Okay, so I like that guy. All right, so let's see. Let's get into quadrant 1. Okay, so we know quadrant 1 would be going from 0 degrees, where if we're just right here and we haven't rotated anywhere. Okay, so that's just 0 degrees right there. And rotate straight due north at 90 degrees, like that. And so our special angles, okay, in quadrant 1 would have to be between 0 degrees and 90 degrees. So that means we would have a 30-degree angle, a 45-degree angle, and a 60-degree angle. These are our special guys in quadrant 1. So let's do them one at a time. Okay, so let's see. Notice here that my theta is 30 degrees. So that means this point right here that's formed where this ray, okay, of the 30-degree angle, which obviously ends up being the hypotenuse of this right triangle, where that ray or hypotenuse intersects the unit circle, okay, these coordinates right here, okay, have to be cosine of 30 and sine of 30, like that. And so you say, okay, well, where do we get that? We did that right here. Okay, so let's see, cosine of 30, okay? Cosine of 30 is radical 3 over 2. So that means this guy has to be radical 3 over 2 for my x-coordinate. And then sine of 30, let's see, where did we do that guy at? Sine of 30 is 1/2, okay? So my coordinates of that point that is formed by a 30-degree angle of rotation is radical 3 over 2 and 1/2. Okay, so let's take that and let's go here. Okay, so this first angle of rotation, starting at 0 degrees and going up to here, that would be our 30 degrees. Okay, and that would have coordinates on the unit circle, radical 3 over 2 and 1/2. Okay, so we have the first part of quadrant 1 done. Okay. All right, so we got the 30-degree angle done. Now the next guy would be the 45-degree angle. Okay, so again, here I have this theta, which is 45 degrees. Okay, so I have this ray, this part of the 45-degree angle that's formed by rotating counterclockwise. Notice that it is also the hypotenuse of this right triangle, and it goes up and it intersects right there on the unit circle. And anywhere on the unit circle, we know we're going to have cosine of theta, which is 45 pesos, and sine of theta, which is 45 pesos. So you say, okay, what are the coordinates there then? Okay, well, let's see, where did we get that? No, not that guy. Here it is, right here. Okay, so we have cosine of 45 degrees is radical 2 over 2, and sine of 45 degrees is radical 2 over 2. So the cosine of 45 degrees is radical 2 over 2, and the sine of 45 degrees is radical 2 over 2. Okay, so we have our second special angle in quadrant 1 in the unit circle. Okay, so this guy right here is formed by starting at 0 degrees and rotating 45 degrees counterclockwise. So that's a 45-degree angle. And the cosine of the cosine of 45 degrees is radical 2 over 2, and the sine of 45 degrees is radical 2 over 2. And don't ever forget this. Remember, everything on the unit circle is cosine theta, your x-coordinate, and sine theta is your y-coordinate. Okay. All right, so let's see. We did the 30-degree angle. We did the 45-degree angle. So now we got to do the 60-degree angle. Okay. So let's see. We got our 60-degree angle. Okay, so again, remember, it starts at 0 degrees and rotates to 60. And so we have this point up here, which I'm just calling P. Okay, and remember that that is on the unit circle, so it has to be cosine of theta, which is 60 degrees, and sine of theta, which is 60 degrees. Okay, and so we say, okay, well, what are those coordinates? Okay, all right, so I go back here, right here. And we say, okay, well, the cosine of 60 degrees is 1/2, so that has to be our x-coordinate. And the sine of 60 degrees is radical 3 over 2, so that's our y-coordinate. Okay, so this has to be 1/2 and radical 3 over 2. Okay, so that gives us our third really important, okay, part of quadrant 1 in our unit circle. So if we start here at 0 degrees and we rotate up to 60, okay, so this would be formed by a 60-degree angle. Okay, and as we saw on that last slide, okay, the cosine of theta would be the cosine of 60, so that's 1/2, and the sine of theta would be the sine of 60, so that's radical 3 over 2. Okay, so all we're left to do is come up with our coordinates for 0 degrees and 90 degrees, and those are the easiest guys to do, because remember, this is a unit circle, so this means our radius, okay, is equal to 1 unit. So this guy would be 1 unit to the right of the origin. So that's at 1, 0. And this guy would be 1 unit up from the origin. So that would be 0, 1. Now, why is that important? Well, the cosine of 0 is 1. You can put that in your calculator and do it, okay? Cosine of 0 gives you 1, okay? The sine of 0 has to be 0. We can do that as well. So if we go the sine of 0, it's equal to 0, okay? And up here, the cosine of 90 would have to be 0, okay? Cosine of 90 is 0, okay? And the sine of 90 has to be 1, okay? The sine of 90 would give us 1. Okay, now remember, everything has to be in degrees here. Okay, so make sure your calculator is in degrees. If it's not in degrees, none of that's going to work out. And that is quadrant 1 of the unit circle. Okay, so this is the easiest part of it. Okay, the rest of it, the cool thing about it is the rest of it ends up being just a reflection of quadrant 1. So if I took that and just reflected it right here, okay, what do I get over here? And if I take that and reflect it down, what do I get over here? And if I take this and reflect it over and then reflect it down, what do I get down in quadrant 3? So tomorrow we'll do quadrant 2, Wednesday we'll do quadrant 3, Thursday we'll do quadrant 4, but this is a good start to it. Okay guys, miss you a whole bunch. See you tomorrow.